This is lesson 5-6, Algebra, Solving Equations. Shonda spends 1/2 hour doing homework after school. Then she spends another half hour doing homework before bed. Write a multiplication expression to find out how much time Shonda spends doing homework. Then find the product. One half plus 1/2 would be the addition expression. We all know that multiplication is repeated addition, so we could rewrite that as 2 times 1/2. The product of those two numbers would be 2 over 2 or 1. Copy and complete the table below. We're going to move down here to have a little bigger table. Multiplying fractions we know is numerator times numerator, denominator times denominator. So 3 over 2 times 2 over 3 gives us 6 over 6, which we can simplify to 1. 1/5 times 5 over 1 gives us 1. 5/6 times 6/5 gives us 30 over 30, which simplifies again to 1. 7/8 times 8/7 is 56 over 56, which again simplifies to 1. 5/7, 7/5 times 5/7 gives us 1. 12 over 12 here, numerator times numerator, denominator times denominator, simplifies to 1. 7 over 1 times 1/7 gives us 1. And 1/8 times 8 gives us a product of 1. What is true about the numerators and denominators in the fractions in exercise 2? The numerators of one fraction match the denominators in the other fraction in every single case. Two numbers with a product of 1 are called multiplicative inverses or reciprocals. The inverse property of multiplication, which is a key concept you can see here, says the product of two numbers and its multiplicative inverse is 1. So 3/4 times 4/3 gives us 1. Again, remember, numerator times numerator, denominator times denominator would give us 12 over 12. Algebraically, a over b times b over a equals 1, provided a or b is not 0. Find the multiplicative inverse of 2/5. We want the fraction, or the whole number, if the case may be, that we would multiply times 2/5 and get 1. 2/5 times 5 over 2 gives us 1 because the product of those two fractions is 10 over 10, which simplifies to 1. Find the multiplicative inverse of 2 1/3. You'll notice here that in order to do numerator times numerator, denominator times denominator, we have to change 2 1/3 to an improper fraction. We've studied that in an earlier lesson. Keep the denominator, multiply denominator times numerator, or denominator times whole number, add the numerator, gives us 7/3. 7/3 times 3/7 equals 1. Check your progress. The reciprocal, or the multiplicative inverse of 5/6 would be 6/5, because the product is 30 over 30, or 1. In B, 1/2 has to change to 3 over 2, so the reciprocal or multiplicative inverse of 1/2 is 2/3. 8 in example C, we would write as the fraction 8 over 1. We would multiply that times 1/8, which would give us a product of 1. In D, 4/3, which is the improper fraction that's equivalent to 1 1/3, we would multiply times 3/4, which would give us a product of 1. In Chapter 3, you learned to solve equations using addition, subtraction, and division properties of equality. You can also solve equations by multiplying each side of by the same number. This is called the multiplication property of equality. It simply says that if 5 equals 5 and you multiply 5 times 2, you multiply both sides of the equation by the same factor, you'll maintain your equality. And it works algebraically as well. If x divided by 2 equals -6 or -3, then x equals -6. Notice again here, we've multiplied both sides of the equation by the same factor. Same thing here. 3 over 2 is the reciprocal of 2/3, or the multiplicative inverse. Multiply both sides of the equation by the same factor, maintain the equality. So 2/3 x equals 4 is an equivalent expression to x equals 6. Solve a division equation. 7 equals n divided by 4. What we're going to do here is multiply each side of the equation by 4 using the multiplication property of equality. And the reason why we do that is because then we get rid of the fraction or the division in our original equation. 7 times 4 equals n divided by 4 times 4, 28 equals n. We go back and we simplify, or we check the original equation by replacing the n with 28. We then evaluate this numerical expression, and we notice that the value 28 makes this equation true. In example 4, we would multiply both sides of the equation by 3.5. We then get d equals 14.7. We substitute 14.7 back into our original equation. We evaluate this numerical expression, and we get the statement 4.2 equals 4.2, which is a true statement. So 14.7 is the value for d that makes this equation true. In example E, 6 equals m divided by 8. What we're going to do is we're going to multiply both sides of the equation times 8. Gives us 48 equals m. When we go back and we check our solution, does 6 equal 48 divided by 8? And of course it does. We're kind of skipping over what's going on here. We'll address that in a minute. Example F, p divided by 2.8 equals 1.5. We're going to multiply both sides of our equation by 2.8. A little tricky using the raised dot here, so we're going to skip using it here, and we're simply going to use parentheses. We want to avoid using raised dots and parentheses in the same expression. P equals 2.8 times 1.5 should give us, I think 4.6. Let's multiply it out. Actually, it's 4.2. If I replace p with 4.2 and divide by 2.8, do I get 1.5? In fact, I do. So the value for p that makes this equation true is 1.5. Or 4.2, I should say. K divided by 4.7. K divided by 4.7 equals 2.3. Again, multiply both sides of my equation times 4.7. K over here equals 4.7 times 2.3. I'm ignoring the decimal points here and just multiplying. I get 14 here. I get 0, 4, 9, 1, 8, 1, 0, 2 decimal places, 10.81. When I replace k with 10.81 and divide by 4.7, do I get 2.3? And yes, I do. So the value for k that makes this equation true is 10.8. Solve a multiplication equation. Now what they've done here is they multiplied x times a fraction. Very similar to a division equation. I could write this one 3/4 x. I could write that as 3x divided by 4. I would solve it the same way. This actually makes it a little simpler. But what I'm going to do again is I'm going to use the multiplication property of equality. I'm going to multiply both sides of the equation by the same number. In this case, it happens to be the multiplicative inverse of this coefficient. Notice I can simplify before I multiply here. Showing you that those two numbers are reciprocals. 1 times x is x. Simplify before I multiply here, I get x equals 4/5. Example H, 1/2 x equals 8. I'm going to multiply both sides of my equation by 2. Actually, I'm going to do 2 over 1 over here. Gives me x here, gives me 16. 3/4 x, for example I. I'm going to multiply both sides of my equation by the reciprocal of the coefficient, which in this case happens to be 4/3. So 9 over 1 times 4 over 3. I can simplify all of these away, which gives me x. I can simplify here and here, which gives me 12. And finally, example J, 7/8 x equals 21/64. Now 21/64, rather large fraction. I'm going to multiply here by 8/7. Again, I can see that these are going to simplify away, give me x here, 8/7 here. Notice how nicely I can simplify here. And what I get is 3/8. X equals 3/8. Made a division error up here. Now let's check that one to make sure that it works. If I have 7/8 x equals 21/64, to me it's not obvious that that's going to work. If I replace the x with 3 over 8 and multiply, do I get 21/64? And if I do numerator times numerator, denominator times denominator, you can see in fact that I do. So the solution to this equation, the value that makes it true, when I replace x with this value is 3/8. Solve each equation, check your solution, 1/2 x. Oh, wait a minute, I think I've already solved those, have I not? Yes, I'm going to skip that page. Valerie needs 2/3 of a yard of fabric to make each hat for a school play. How many hats can she make with 6 yards? Well, 2/3 n equals 6. Here's the equation. She has 6 yards. She wants to divide by 2/3 or multiply by 2/3. In this case, she's going to multiply both sides of the equation by 3 over 2. She's going to find that she can make 9 hats. Wilson has 9 pounds of trail mix. How many 3/4 pounds bags can he make? Well, very similar equation. 3/4 times the number of bags he can make is going to equal 9 pounds. So what he's going to do is he's going to multiply both sides of the equation times 4/3. In this case, these two numbers are reciprocals or multiplicative inverses. Multiply this side of the equation by the same value. Simplify before you multiply. How many bags can you make? 12. Find the multiplicative inverse of each number, 8/5 times 5/8 gives me 1. I'm looking for the value that when multiplied times the first value gives me a product of 1. Number 2, 2/9 times 9 over 2 is 1. 5 4/5. Have to change that to an improper fraction. That's 29 fifths. So my multiplicative inverse is 5 over 29. 9, I would write as an improper fraction. Its multiplicative inverse then is 1/9. Solve each equation. Number 5. K over 16, or K divided by 16 equals 2. I'm going to multiply both sides of my equation by 16. K equals 32. Does 32 divided by 16 equal 2? Yes, it does. Number 6. 4 equals y divided by 3. Multiply both sides of the equation by 3. Does 12 equal y? If I replace the value for y in my original equation, does 12 divided by 3 equal 4? Yes, in fact it does. B over divided by 8.2 equals 2.5 for number B divided by 8.2. This is example number 7 up here, equals 2.5. I'm going to multiply both sides of my equation by 8.2. Again, being careful of the decimal point. B equals 8.2 times 2.5. Multiply this out the long way. There's 41. 0, 4, 16, and I get 0, 5, 20.50, which is the value for B that makes this a true statement. Number 8. Um, 0.5 equals h divided by 3.6. I'm going to multiply both sides of my equation by 3.6. 3.6 times 0.5 is 1.8. Does 1.8 equal h? If I replace it in my original equation, does 1.8 divided by 3.6 equal 0.5 or 1/2? Yes, in fact it does. Number 9, 3/8a. Now we're going to a multiplication equation. Very little difference in how you solve these, because multiplying and dividing are basically the same. Dividing is multiplying by the reciprocal of the divisor. So I'm going to multiply here times 8 over 3. I'm going to multiply here times 8 over 3. These all simplify away. This is a. I can simplify here, and here, and here, and here, and a equals 4/5. Does 3/8 times 4/5 equal 12 over 40? I think it's clear that it does. And the last example. 6 equals 4/7 x. I'm going to multiply both sides of my equation by 4/7, and they've messed with me here by putting my variable on the right side, but I'm going to deal with that. I'm going to say 4/7 times 6 over 1 equals, actually that's not 4/7, it should be 7/4, because I want the reciprocal of the coefficient, not the coefficient. So this is going to be 7/4. 7/4 here times 4/7 equals x. These simplify away. This equals x. I can simplify a little bit here. I can divide this by 2. I can divide this by 2. I've got 21 over 2, which is 10.5. Strange looking answer. Should check that. I'll do it later. 3/4 of the fruit in the refrigerator are apples. There are 24 apples in the refrigerator. The number of pieces of fruit is given by the equation 3/4 f equals 24. How many pieces of fruit are in the refrigerator? To solve for f, I'm going to multiply both sides of my equation by the reciprocal of the coefficient. In this case, these again simplify away. F equals, simplify here and here. How many pieces of fruit? 32. Dylan deposits 3/4 of his paycheck into the bank. The deposit slip shows how much he deposited. What was the amount of the check? So we're going to write the equation. 3/4 of the value that we don't know is $45. So we're going to multiply both sides of our equation by 4/3. Change 45 to a fraction. Again, these all simplify away. X equals, we can simplify here by dividing by 3. This is 15. What was his check? $60. Our vocabulary in this lesson, the multiplicative inverse is the product of a number and its multiplicative inverse is 1. That's the definition. Reciprocal is the multiplicative inverse of a number. My definition for reciprocal I like a little better. I say two numbers whose product is 1 are reciprocals. In this case, I've written it algebraically. Two numbers whose product is 1 are reciprocals. At this point, you should quit watching the video, go back to my Moodle page, log in, take lesson quiz 5-6. Remember, your username is your 6-digit student number, and your password is the first 6 digits of your last name.